Hello everyone, today I am going to demonstrate stock market predictor using hybrid models. We mainly have two datasets for this purpose. One with the dataset containing the actual historic stock prices including numeric parameters like volume, open, close, date, high and low. The second dataset contains date, label and news headlines. The label parameters in the dataset has values 0 and 1. 0 indicates the market will fall and 1 will show the market will rise. There are two ways of executing this project. First, we can convert the news headlines into numeric format. That is, we will use sentiment analysis to know the sentiment of the news. We return the parameter of the headlines into simple numeric format and then use machine learning technique to execute it. Second, we can directly use labels table as an input parameter from news headlines and feed the data to the ML model. We will use ML to train the dataset and give us the result. In both the cases, we are going to use LSTM, long short-term memory. The algorithm essentially learns from the previous data and carry forwards some part of the data to predict. So before starting the entire project, we just need to install some dependencies and we'll just import the necessary modules that we need for this project. As I said, we have two data sets for this purpose, so we'll import the data in variables called df1 and df2. So the combined news djia is the data set containing the headlines. Okay, so we have stored it in df1, and as you can see, it has a shape of 1989, 27, and the second data set containing the historic stock prices will store it in df2. Okay, and as you can see, they both have the same number of rows, so that is great. And we have these two dataset. Now we need to actually merge those both of the dataset. So we can merge both of the dataset using the label date, okay, using the column date. So if the date of a row is same, we'll merge them. So we are doing this by using the inner join method. I won't go deep into the join methods. Now we are using our inner join. So we have joined the table and we have stored it in merge variable. So let's see, this is our table, and as you can see, everything is merged according to the date, headlines, as well as the historic stock prices. After that, as you can see, we have the shape of the variable, our table, and is again 1989. So that is great. So now what I'm trying to do is we need to actually merge everything. There are 25 of headlines and we don't want all of them separately. We'll just combine each and every headline into one single column, so it is easier for us to process the data. So before doing that, as you can see, there are a few the data is uncleaned, so there are slashes, there are commas, inverted commas, okay, and also a small letter b everywhere. So we'll use a few lines of code to remove it, and the data is cleaned now. And after cleaning the data, we'll store it in a new column called as combined news, and we'll store that the new column will be under the merge variable, which pre-existingly was storing all the variables and columns and data. So let's see how the merge table looks like. Okay, so all of those 25 news headlines are stored in one single column called combined news, and the data is cleaned. Okay, so yes, subjectivity and polarity, this is where the main concept comes in, the way we are going to actually convert our words into numeric values. So we are just going to convert our news headlines into numeric format so that we can use it for LSTM. So what is this get subjectivity function? It will basically return a float value, and subjectivity generally refers to personal opinion, emotion or judgment, and the value of this function will return in a range of 0 to 1. Polarity, it tells us whether the statement is positive, negative or neutral. The range will be between 0 to 1. So this function will actually return us a value where subjectivity will return a value between 0 and 1, and polarity will return a value between -1 and 1, where -1 means a negative statement, 0 means a neutral statement, and 1 means a positive statement. Great. So for each and every news column or row, we need a numeric format, right? So we are using this function where we are actually sending our combined news value inside this function to get a numeric value, and we are storing it in a new column called subjectivity and polarity. Great. So let's display our merge table again. So as you can see, we have subjectivity and polarity again. After that, we are using a function SIA, that is sentiment intensity analyzer. So this is similar to the previous one. So in this case, what we are doing is we are creating a variable or list called compound, negativity, positivity, neutral, and SIA. Okay, SI is not a list, but it is a variable. So the compound means the score or metric that calculates the sum of all lexical readings which are normalized between -1 to 1. Okay, so this is similar to the upper one. There is slight difference between them. So if we add these three values, that is negative, neutral, and positive, we will get a value. Okay, we'll get a constant value. So let's just see, if we add all these three values, we'll get the answer as 1. Okay, so even if we take just two values, that is negative and neutral, it will give us the same results as this model. We can delete the positive column for redundancy. So as you know, we don't need this column stock on top 2, top 3 till top 25. We don't need that, and also we don't need the combined news column now. So I'll just select what columns I need for this purpose. So I've selected the given columns, and as you can see, I've displayed it, and you can see there are a few columns that are actually necessary for creating the model. Now the close column is what we need to predict. So I've stored that in a value called df1, okay, in a variable called df1. Let's just display what it has. So as you can see, on the 0th index it is 11734. So see, on the 0th index it is 11734. After that, I've used matplotlib to actually plot our close table. So this is the range of close from 6,000 to 18,000 over a period of almost 5 years, and there are 365 days in 5 years, so it is approximately 1900 values. So as you can see, from from the first day, that is the 0th index, till 2000th of the index, that is 1900 days almost, we have the values. Okay, after that, a few more models needed to be imported, and now for actually processing the data in LSTM, we need to pre-process the data. So we are using min-max scalar function. It will basically convert our values into values that range between 0 and 1. So our close column will be now converted into 0 to 1 values. It will return us a float value. Okay, and now we are actually splitting the data into training and test size. So we are using 65% of the data for training and rest of it for testing. Okay, so again here I've used training and test data for splitting. Okay, we also need to reshape the entire data we have in xtrain and xtest that is necessary for LSTM. So here comes the main part. We need to install a few necessities, dependencies for LSTM, and just import it using this lines of code. And after that, we are actually storing or creating our model in the variable called model. Okay, and for that we are going to use 100 elements. So basically, it will learn from past 100 data values. So this is what this line means. And the optimizer we are using here is Atom. There are other optimizers as well, but here we are using Atom. Okay, so after that we just need to fit our model, fit our data set inside the model and train it. So this will take the values xtrain, ytrain and validation data, and we are using 100 epochs for this purpose. So as you can see, it has used 100 epochs. So our model is trained now, but we actually need to check its accuracy. Okay, so what we're doing here is we are actually giving the xtrain as the data, and the ytrain, which will contain the close column, we are storing the predictive values of close column inside train predict. Okay, and now we can see a better result, and I've used a few lines of code to actually show how our model is performing. So the blue line will show us the actual data, the orange line will show us the predicted data on training set, and the green color will show us the test data predictions. So as you can see, it is overlapping, so it is giving great result. Great. So this entire application is about stock market prediction, right? So we need to predict data of next 30 days. So how can we do it? So I just print the length of test data. It is 697. And how do we train it? So let's say we are training it using the last 100 days data. So I'll just minus 697 minus 100, that is 597. So I'm using past 100 cells for training it, and I'm using we need to calculate data for next 30 days, right? So I have used a loop to actually process data for next predict data for the next 30 days. So it will just give us some values, and yes, we are using 1 to 101 because the values will get added to the original input. Okay, so we don't want the original input, we just need the predicted input output. So we'll use the index 1 to 101. Okay, and after that we need to inverse the transform. We need to use inverse transform, because when we used min-max scalar method, the function, we actually converted the entire data set into the values that ranged between 0 and 1. So now we need to convert it back to its original format. So we converted it using these values, and we have plotted the data for next 30 days, and it is giving us a straight line, and it is pretty good. And as you can see, if we further train it well for more days, it will give us a more accurate value on a larger data set. And after that, yes, you can see this small line. Yes, that is what our prediction is, that the market will go sideways. It will neither go up or down. So yes, this was the implementation part number 1 of the project, and our model is performing well. So congratulations.